Good morning, all. My name is David McCormack, and I'm the Director for Sustainable Manufacturing in Irish Manufacturing Research. Today, I will be talking to you about why a circular economy is pivotal to Ireland and how industry can take steps to transition from a linear to a circular business model. If you have any questions throughout the presentation, please use the app to ask them, and I will answer as many as possible during the Q&A session. Firstly, a little bit about IMR. IMR is a mid to late stage technology readiness level centre supported by Enterprise Ireland and the IDA. IMR was established in 2014, incorporating ICMR and I2E2, two industrial networks, to position Ireland as a leader in advanced manufacturing. And it does this by demystifying, de-risking and delivering emerging technologies and concepts for manufacturing in Ireland. We have four key thematic pillars: digitization, which looks to help industry gain value and competitive advantage from data through extraction and transformation; automation and advanced control, which helps industry develop and deploy automation and control techniques and strategies; design for manufacturing, which looks to help industry design and manufacture complex products and processes on emergency technologies such as additive and subtractive manufacturing. And then finally, sustainable manufacturing, where we look to help industry on their sustainability journey towards a zero carbon manufacturing facility by driving innovation across material, energy and water nexus. For example, like our flagship circular economy project, Circularity, the national platform for circular manufacturing. Circularity is a public-private partnership created by IMR and the Department of Communications, Climate Action and the Environment, the EPA and EIT Climate Kick, with 25 founding members. And it aims to address the circularity innovation gap in Ireland by using manufacturing companies and their supply chains to role model a transition to a low carbon circular economy. It will do this by co-creating solutions for industry through large scale demonstrations that prove the value of the circular economy. This slide shows the current circular members and the cross-sectoral nature of the programme, which allows peer-to-peer learning and a space to foster collaboration. And as you can see, we have representatives from the pharma, medical device, plastic, food, drinks and furniture. So these companies are taking the circular economy seriously and want to understand how it can apply to their business. Okay, into the presentation proper now. So why is the circular economy pivotal for Ireland? As we walk the path to recovery from COVID-19, scaling circular economy implementation can increase Ireland's competitive advantage and resilience to external supply chain shocks, which we've currently experienced in COVID-19. We need to make circularity central to the Recovery Fund, the National Economic Plan and the National Development Plan. We have an opportunity to mirror circular leaders, countries like Slovenia, who have committed to becoming circular by 2030 and are therefore positioned to maximise the drawdown of EU regional development and structural funds, which now the EU Green Deal sets the principles for access going forward. Furthermore, implementing circularity is pivotal to Ireland's decarbonisation goal of halving overall greenhouse gas emissions across the economy by 51% between 2021 and 2030 and achieving net zero emissions by 2050 as laid out in the Programme for Government 2020. So why is circular economy pivotal to this? So up until recently, most of the efforts to combat climate change have focused mainly on the critical role of renewable energy and energy efficient measures. However, meeting climate targets will also require Ireland to tackle the emissions associated with making products. A circular economy offers a systemic and cost-effective approach to tackling this challenge. A circular economy, by its design, aims to maintain the value of products, materials and resources in the economy for as long as possible while minimizing the generation of waste and material inputs through the likes of eco-design, recycling and reusing of products. The circular economy offers significant potential for climate change mitigation as it helps by reducing greenhouse emissions that occur over the life cycle of the product from production to disposal. So I can't not talk about COVID-19 and the impact it has on manufacturing to date. But like every crisis, there is an opportunity to reflect and change how we do things going forward. So as we are aware that COVID-19 has had and is currently having significant impact on all sectors of society, here are some of the types of impacts on the manufacturing sector to date. In the pharmaceutical sector, COVID has put the global supply of medical products under tremendous pressure. For example, China is the world's leading producer and exporter of pharmaceutical APIs by volume. Ireland, like any other pharmaceutical manufacturing nation, relies heavily on sourcing material both directly and indirectly from China. India, another leading API manufacturer, has halted the export of 26 ingredients commonly used in pharmaceuticals in its effort to ensure uninterrupted availability of critical APIs. COVID has also forced many pharma manufacturing companies to focus on the production of masks, ventilators, and related components such as hand sanitizers. This way, they have been able to minimize the impact of the pandemic to some extent, but this cannot be their long-term strategy. The food and beverage manufacturing industry. A recent survey carried out by a trade group, Anya, suggests that the food and beverage companies have suffered a 22% loss in turnover globally. In the current scenario, food and beverage manufacturing companies are facing significantly reduced consumption as well as supply chain issues. The shelves in the shop witnessed the scarcity due to panic buying, and the supply of raw materials and ingredients to the manufacturing site has been badly affected, which has hampered production, forcing manufacturers to pause operations and in causing supply chain derailment. While at-home consumption has shown a spike, the commercial sector, the hotels and restaurant consumption, which traditionally generates the high margin, has come to a standstill. In other sectors, such as the chemical manufacturing industry, the pandemic has resulted in a global chemical production decline by 4.3%, and specialist chemical production declining by 9.5% as of June 2020 compared to previous years. This crisis has forced the leading chemical manufacturers around the globe to reduce capital and operational expenditure, scale down their manufacturing operations to 40 to 60% capacity due to labour shortages, reduced demand, potentially tightening credit markets, and a shortage in raw material supplies. This then has a knock-on effect to many production facilities of several end-user industries, such as the plastics, fertilizers, medicine, and packaging, etc. All of these major sectors in the processing manufacturing industries are suffering in the time of COVID-19, with reduced demand and disrupted supply chains being the major issue. However, with challenge comes opportunity. Once the dust settles, the process manufacturers will find it imperative to innovate and change with time to remain relevant. Moving the focus to Ireland now. So where does Ireland actually rank in terms of circularity? Currently, there is a circular innovation gap in Ireland. So according to the EPA, Ireland uses greater than 100 tonnes of material annually. Coakley et al. Produced a report in 2013 stating that a 5% material improvement could yield a €2.3 billion per year opportunity. A NESC 2017 report states the full potential of circular economy in Ireland has yet to be identified, never mind realised. The Murphy et al. Report in 2019 states that the €2.3 billion per year opportunity has largely been uncapitalised to date. The NESC report calls for the need for brokers to bring sectors together, tailored institution supports, and new networks to foster cross-sector collaboration to build circularity knowledge, to increase capacity, and ultimately close the implementation gap. So if we look at the EU Eurostat figure on circular material use, which measures the share of material recovered and fed back into the economy, thus saving extraction of primary raw materials, Ireland has a rating of 1.6% circular, which is a long way off the EU average of 11.7%. And as you can see from the figure below, it has remained relatively constant over the last 10 years, backing up the Murphy et al. Report stating that the circular economy has been largely uncapitalised in Ireland. So how do we close this implementation gap, and what's required from an industry perspective? The following are some key items industry will require to drive the transition to a circular economy. From a materials perspective, we need pure secondary raw materials or material substitutes at sufficient volume. We will require an enabling infrastructure and markets to aggregate waste byproducts, ensuring economies of scale. The data, we will require material information that will enable us to recover and reuse products through recycling, etc. Standardization, regarding specifically end of waste criteria, we need to learn from other EU countries where byproducts are already being utilised safely. Policy, we need to ensure policy coherence across all government departments, a step which has been called out in the recently published Government's Waste Plan for Action for a Circular Economy, which aims to set up an interdepartmental circular economy group. Policies could also incentivise circular strategies as the new norm, create economic incentives to develop circularity. From an industry perspective, looking inwards, like everything, you need to know where you're starting from to understand where you're going. So companies familiar with ISO 14 and 50001 would be used to this approach. So taking a phase base, so you would start with a baselining exercise of the materials, energy and water consumption with the factory. Phase 2, carry out a circular maturity assessment to understand the business readiness to transition towards a circular business model. In phase 3 then, based on this maturity assessment, a learning and training gaps would be identified, and these can be filled either by upskilling the current staff or by hiring in the skill set. Phase 4, carry out a detailed site assessment, which will lead to the development of a register of opportunities and a circular action plan, before moving into phase 5, implementation. So I'm going to cover over the next few slides types of circular strategies that could be deployed by industry during an implementation phase. So we have a reuse and share use model, where reuse refers to when a product or a component is used again for the same purpose. Shared use refers to a collaborative consumption, example, peer-to-peer or business to customer, or asset sharing, business to business. Design for circularity. This gives priority to design principles and strategies which enable materials, components, and products to have multiple use lives in our economy. A product as a service describes the transformation of a traditional product offering into a product service model where ownership of the product is retained by the manufacturer or distributor. An example of this could be chilled water as a service in the future. So a distributor would supply the 6 degree or 4 degree chilled water to the industry, and they would be responsible to make sure that it was displayed on an efficient basis. Remanufacturing. So remanufacturing is when a used product is returned to the standard of an equivalent new product. Remanufacturing involves the disassemble, restoration and replacement and testing of the individual components and the product itself to ensure it complies with its original design. Example of this would be Caterpillar's Cat Remain program that returns products at the end of their serviceable lives to the same as new condition. This helps reduce ownership and operating costs by providing companies with the same as new quality at a fraction of the cost of the new part. Through the remanufacturing process, Caterpillar reduces wastes, lowers greenhouse gas production, and minimizes the need for raw materials. Repair, as we're all familiar with, refers to the process through which apparent faults and product malfunctions are rectified. Refurbishment itself goes a step further and entails activities to refinish and sanitize a product so it is fit to serve its original function. Take-back schemes are programs implemented by companies to recover products or packaging from end users so that they can repair, reuse, remanufacture, or recycle to recover the embedded value in raw materials. Take-back schemes are underpinned by what is referred to as reverse logistics. Circular procurement. Circular procurement sets out an approach to green procurement, which pays special attention to the purchase of works, goods, and services that seek to contribute to the closed loop energy and materials loop within the supply chain, while minimizing and, in the best case, avoiding negative environmental impacts and waste creation across the whole life cycle. This approach can lead to multiple benefits. For example, as well as delivering potential savings, circular procurement also provides a framework for a more holistic consideration of environmental impacts and the waste creation across the whole life cycle of the services. Recycling. So there are three types of recycling: mechanical, thermodynamic, and energy recovery. Mechanical refers to the residuals when the residuals are mechanically transformed without changing the chemical structure. Thermodynamic involves breaking materials into their modular components to create raw materials for new products. Energy recovery by combustion, a last resort, is when waste is transformed into usable heat, electricity, or fuel. Industrial symbiosis refers to a collaboration between two or more geographically close companies where residuals or byproducts of one industry or industrial process become the raw materials of another process within the manufacturing site. Industrial symbiosis is a well-established and proven across Europe and potentially could have significant impact for Ireland if replicated. For example, there are a number of industrial parks around Ireland where waste heat and cooling could be shared. Furthermore, there's an opportunity for new industrial FDI coming into the country to be surveyed from an inputs-outputs needs assessment to understand how they could be co-located in existing industrial parks or new industrial symbiosis parks created. So finally, my last slide, and just to recap, the circular economy is important to Ireland because it can deliver economic growth, it can increase supply chain resilience, and it's imperative for the future access to EU regional development and structural funds under the Green Deal. It is also strategic to Ireland's decarbonation goal, as the circular economy offers significant potential for climate change mitigation, as it helps by reducing greenhouse gases that occur over the life cycle of the product from production to disposal. It can also enable Ireland's post-COVID-19 recovery by job creation and retention. How do we go about doing it? Well, there is a need for pure secondary raw materials at sufficient volume, the infrastructure and the markets to aggregate waste byproducts, and the correct data and material information that will enable recovery for reuse and recycling, coupled with cross-governmental policy coherence. The benefits for industry: on-site carbon emission reductions in consumption across the resource nexus, resilience to resource price volatility and supply chain shocks, new revenue models and value creation opportunities, and potential new customer relationships and enhanced customer loyalty. And that's me. Thank you very much for your time today, and thanks to the EPA for inviting me to speak. If you want to know more about our Circular program, you can contact circular@imr.ie.